Bismillahirrahmanirrahim. Greetings. This is going to be the fourth video lecture that I'm uploading about the concept of rate, ratio, and proportion. Now, in this lecture, I'm going to go over the material that we have covered in previous lectures and add a few more words in it. And in the next lecture, I'm planning to wrap up and generalize the idea and come up with a solid, in a sense, deductive mathematical formula that we can use it for all similar problems as the problem that we are going through. Okay, then let's get started, shall we? Now, initially, we started with a problem that we had difficulty to begin with for the solution. So we came up with a similar problem, similar example of our own that we knew the answer, and we want to use that one as a prototype to solve the hard problem. The problem that we made it up ourselves, was that we had a club of 15 members. You see, the university initially that we started was 25,410 number of population. So we reduced that population to 15 so that we can manage it and feel it what's going on. And then the ratio of them was 4 to 3 to 2 to 1, and here we are making the ratio of male to female of that 15 members of the club to be 1 to 2. You see how much simpler we made the problem. And then we want to know how we come to the answer. So one thing we did is that we made a pictorial demonstration. We decomposed the set of 15 members into subsets of 3 members in the ratio of 1 to 2 male to female. Now, I am using the word set and subsets, but not in a mathematical meaning, because set and subsets, they have restricted mathematical meaning. One of the characteristics of set is that should not have any repeated elements. But in our collection of 15 members of the club, we have quite many repeated elements. So I am using the word set and subset to convey the idea, as I have mentioned in the previous lecture. Okay, then what we did after from that observation, from that pictorial demonstration, we noticed that we get 5 equivalent subsets that each of them they had 3 members of the club in the ratio of 1 to 2, 1 male and 2 female. Now we want to correspond this one to mathematical equation so that mathematics can represent that one for us. So we look at that, it looks like that if we divide 15 by 3, and 3 to be the ratio of 1 and 2, we add 1 and 2, that is 3, divided into 15, we get that magic 5 that we were looking for. And that 5 indicates that we have 5 male and 5 times 2, which is 10 female. So the entire club should be in the ratio of 5 to 10, 5 male, 10 female. But now the point is that we have no problem with the number 15. 15 is the number of population in the club. But we do have problem with this 3. What is 3? Then, as I mentioned in the previous lecture, 3 by itself has no meaning. Is an abstract number. And I did compare that one to the adjective, like saying good man. Good by itself has no meaning. It's a word in English. But when it is attached by a name like man, then it gives the quality of that man. And in contrast, exactly same goes with the number. So 3 has no meaning by itself, but when we attach that one by a noun like apple, then it gives the quantity rather than quality. All right? Now here is, how do we know that 3 represents 1 male and 2 female? It's abstract number. How do we know it's not representing 2 male, 1 female? How do we know it's not representing 3 male or 3 female or even 3 apple, which is nonsense, huh? Now, the number 5, the quotient, answers all of these questions. Very interesting, huh? So that we have justification for that. So let me go put now the stuff that I said in writing. Let me zoom it up, and I stay out of your way, and I go over the same material again, but in writing, so that you hear that for the 3rd time in a sense. Okay, let me stay out of your way. Here is that, it says, let's call the given ratio of 1 to 2 of male to female as the unit ratio. We call it unit ratio. Is a name that we put on it. It's not the standard. And doesn't matter because we want to communicate and convey the message, convey the knowledge. Then what happens? Then according to our pictorial demonstration that I have it here from the previous lecture, then the ratio, the ratio of male to female of the total population of the club came out to be 5 male, 5 1 standing for male, and 5 times 2, which is 10 what? 10 female, because there is a ratio of 1 to 2. Do you follow me? Now, the demonstration was this, if you may recall from the previous lecture. Let me hold it up. And it is more explicit in the other lecture that I have given. Now, in the demonstration, what I did partition the set into what? Into 5 equivalent subsets. Equivalent means they all are the same, because there are other ways we could partition the set. And then we end up to be what? 5 of them we made by doing that. 1, 2, 3, 4, 5. And that means we have 5 male and 5 female, pictorially. So that, now let me see what this pictorial representation can give us what, give us the number 5. Now our goal is to determine a mathematical procedure to what? To obtain this number 5, the magic number. Okay, let me now put the next one up. Now, by doing that, it seems like if we divide 15, the number of what? The number of population of the club, the total population of the club, by 3, what was 3? 3 seems like to be the sum of 1 and 2, which is, we call it the unit ratio of 1 to 2. We do get that what? We do get that number 5, which is the magic, because 15 divided by 3 equals to 5. Is that right? No. Then I'm using but. This is only an observation. We need some kind of what? Justification for that. Then we know, then I continue and I said that we know 15 is what? Is the total population of the club members. Is that right? We do know that. But how do we know 3 stands for the sum of 1 male and 2 female? That's the question that improves your critical thinking in reality, and is an excellent question to ask. And this is what this kind of question makes you to be Carol Gauss. Now, let's see how we can come to the answer to that. Huh? As I repeat myself, it's a very good, curious question to ask. Now, the answer is this. He says that We know 3 by itself, as I already mentioned orally, 3 by itself is an abstract number, is that right? It has no soul. It has no soul to make a selection for itself. It has no magnet. It has nothing to do. It's just abstract number. No, he can't make any selection, or any other numbers like that, like we call them adjective. Is that right? Once a noun is attached to them, then like tree apple says tree apple, then tree stands for what? Quantity of that. Now, question is this: how do we know our tree may not represent 3 male? How do we know our number 3 does not represent 3 female? How do we know our 3 does not represent 2 male plus 1 female, which is that is 3? How do we know it does not represent anything else like 3 apple? Is that right? Now the question of 15 divided by 3 gives the answer. I repeat myself, the question of dividing 15 by 3 gives the answer to all these questions. Now let's see how we can discuss that answers. Now, in our example, 3 may not represent 3 male. Why not? Why 3 cannot represent 3 male? Because if 3 represent 3 male, then the number 5, the magic number that we got, then 5 times 3 makes 15 male, and that contradicts what? Contradicts the premises of the given problem. Because the given problem didn't say the entire members of the club were male. They said they are male and female, mixture of them. So this is out. So the 3 cannot represent what? 3 male. Now how do we know that 3 does not represent 3 female? Again, exactly similar, same analogy. So cannot, because in that case all the members of the club would have been female. And again, contradicts what? The premises in the problem. Now the other question that comes up is that how do we know that 3 may not represent, let's say, 2 male and 1 female? Why not? Why should it be 1 male and 2 female? How do we know it's not meaning 2 male and 1 female when divide 15 by 3? The answer of that is that if this is the case, then when we multiply by the quotient, which is 5, then we get 5 times 2, which is 10 male, and 5 times 1, which is 5 female. Then what happened in that case? In that case, the ratio is violated, because he says the problem indicates that the ratio of male to female is what? Is 1 to 2. But if this is the case, then the ratio of male to female will be 2 to 1. So that also violates the what? The premises of the problem. So this is also out. So we know that the 3 cannot represent apple. That is a joke. So it looks like the only one left for us that can solve our problem, justify that one, that 3 should represent 1 male and 2 female. Because when we multiply by 5, the quotient, we get 5 what? 5 male, and we get 5 times 2, which is 10 female. So we get the ratio of the population of the club to be in the ratio of what? 5 to 10, which is same as 1 to 2. All right, now let me zoom it back so that I can say a few more words. Okay then, I hope that this lecture was beneficial to you, and as I'm repeating myself, next I'm going to make another example to give us more confidence, and then I'm going to generalize that one and come up with a deductive mathematical formula for that. So that will be for the coming lecture or lectures, maybe one or two more lectures I will be uploading. Okay, then I thank you all for watching, and as always I wish you prosperity and good health, and please stay safe. So long.